Let's start our dev recap. We have a lot of nice, awesome things to share with our community. So let's start. Since was Diego's birthday, let me see if Vitor Fusco is already here to start with the machine emulator team update. Are you
Hello,
here?
Claudio.
Hey, Vitor.
Good morning.
Good morning. The mic is yours, my friend.
First, uh, happy birthday, Diego. I didn't know that. All right. Welcome, everyone. Today, we're introducing VirtuIO support on the Cartesi machine, a strategic move aimed at enhancing usability, reducing development cycle times, and minimizing the technical overhead for common tasks. This feature is about bringing Cartesi machine experience closer to what developers expect from well-established emulators, virtual machines, and Docker environments. So, without further ado, I will ask Eduardo to present. Eduardo, are you there?
Hello, can you hear me?
Yes,
Sure.
Eduardo. Welcome.
So let me share my screen. Can you see the screen?
Yes.
Okay, so I'm going to talk about VirtuIO. It's a new feature we got implemented in the Cartesi machine. So first, what is VirtuIO? It means virtual input and output. It's a way to allow a virtual machine to access the host machine state. So you could access files on the host, network of the host, and also have more features in the terminal, like bigger terminal, and it's resizable. It's a specification supported by many emulators and virtualization software, like QEMU and VirtualBox, and it is now also supported by the Cartesi machine emulator. So why VirtuIO is useful for the Cartesi machine? First, it brings three new devices. First, the VirtuIO network device. It allows to access the internet from inside the Cartesi machine. It also allows to run web servers inside the Cartesi machine while exposing to the external world. Then there is also the VirtuIO Plan 9 device. This device allows to manipulate files on the host system from inside the Cartesi machine. And finally, there is the VirtuIO console device. It allows to resize the terminal and also make it more responsive. So these three new devices are useful mostly for prototyping application. So you could use them to make live changes to an application while testing directly in a Cartesi machine environment. And you could also use them to do some remote debugging of applications running inside a Cartesi machine. And it's also useful for manipulating a rootfs using Cartesi machine emulator itself. So you could use a Cartesi machine instead of Docker and QEMU to manipulate the rootfs. But one thing a disclaimer to make is that VirtuIO cannot be used by a node in production. I will talk more about this later. So here I'm going to show a demo of using VirtuIO with the network. So here I'm booting up the Cartesi machine. The first command line argument is starting as root, and the second command is enable network, and the third is enable interactive terminal. Notice that the terminal has colors now. This is because the new virtual terminal device. Notice also the date. It's sync with the host date, because to access the internet we need a date sync with the host. Then I'm going to ping Cartesi.io. Notice that we can ping from inside the Cartesi machine. Then I'm going to access the Cartesi.io website from inside the Cartesi machine, so you can make weather requests from inside the Cartesi machine. And finally, I'm going to install an application in this session. It will download it from the internet and install in the system. I'm gonna fast forward a little because it takes some time to install it. So here it's installed 8 top. Now I'm gonna run it. Notice that the terminal is bigger. We can resize it, and also has colors. All this inside the Cartesi machine session. And finally, I'm gonna print an emoji here. So the terminal now supports all emojis. So this was the first demo of network demo. Next, I'm going to show sharing files on remote debugging demo. So here I have on my host an editor open with some dApp code. And I'm going to access those files on the host from inside a Cartesi machine, expose those files on the host from inside a Cartesi machine. Notice also this port forward argument. It's going to expose the port 1, 2, 3, 4, so the host can connect to a Cartesi machine. Notice the volume option here. It's gonna mount the app directories on the host inside the mount directory on the Cartesi machine. So here it's booted the Cartesi machine. Notice that this file, main.c, that's on the host, is inside the Cartesi machine. Now I'm going to edit this file on the host, and these changes will be available in the inside the Cartesi machine. Notice here that file was just saved, and you can also edit from inside the Cartesi machine this file, and these changes should be made outside. Notice here that the changes make on the host. Now on the host, I'm going to cross-compile this main.c to a RISC-V binary, and then it will be available inside the Cartesi machine. Notice here, it's compiled in here. And now I'm gonna run this application. This application has a bug, intentionally made this bug because we are going to debug it while inside the Cartesi machine. So I'm here running GDB server, and the GDB server is listening on one port 1, 2, 3, 4. And now on the host, I'm going to start a GDB front end, connect to it, and debug. So here it started a GDB front end on the host. It connected the Cartesi machine. It started the program. The program printed hello. Then it crashed. You can see segmentation fault. And you can see the traceback here. And you can debug it from outside the Cartesi machine, an application run inside it. So this was the sharing files and remote debugging demo. Now, finally, the last demo I want to show you is manipulating rootfs. So in this demo, I'm going to boot a machine from pre-built rootfs, and I'm going to manipulate it using files from outside, from the host. Like here, I'm copying an application from the host files inside this rootfs, and also downloading some stuff from the internet inside this rootfs. Notice the two files were created in this rootfs, and just shut down the machine. And this rootfs should have saved those changes. And now I can boot the machine again. And these files should be available there. So we can use virtual also to manipulate rootfs. Notice I booted the same rootfs file, and this main and readme files were there. So this is the last demo. And now I'm going to talk about some limitations about virtual. It's important to say that machines using virtual are non-reproducible. This is because the host machine state becomes parts of the Cartesi machine state. So host network connection is part of the state, host files and directories, and host to terminal size. All those things are outside the Cartesi machine, so the machine is non-reproducible. Because machines are non-reproducible, they cannot be merkleized, so you can't compute its root hash. And machines using virtual also cannot be stored or resumed. And machines using virtual also cannot fork, so you can't revert its state. Therefore, virtual cannot be used in production by a node. However, the rollups device will still work, but the machine cannot revert its state on reject, advanced, and inspect states. And virtual right now is supported by Linux, Mac OS, but not on Windows yet. So wrapping up everything, the Cartesi machine emulator now supports virtual device. Virtual allows accessing the external network, sharing files, and better terminals. It can be used for prototyping, remote debugging, or as an alternative to Docker and QEMU for running software inside a Cartesi, inside a RISC-V environment. Machines using virtual are non-reproducible, therefore cannot be used by a node in production. And the Cartesi machine emulator now is also more closer to prototyping features offered by other virtualization software like QEMU and VirtualBox. And finally, the virtual implementation is finished and under review. It should land in Cartesi Machine Emulator SDK 0.17, expected to be in March 24. So that is it. Then I finished my presentation.
Awesome, Eduardo. Thank you. This is really awesome.
Thanks.
Claudio, this is the update for today. So back to you. Thank you.
Thank you very much, Vito, Eduardo, and all the Machine Emulator team. This was really, really awesome. No words. So let's move on to see what other units have prepared. Linneo and Node unit or contract? Who wants to be the next?
I guess we can assume from here. It's always a tough spot to present something after Eduardo does a demo, but I'll try my best.
Yeah. Welcome, Yves, Linneo. The mic is yours, guys.
Hello.
Let me share my screen. Okay, guess we're all good. So, hi people, my name is Yves. I'm here to update everyone on the latest news from the Node reference unit. And in particular, I would like to focus on our upcoming release, version 1.3. We're really excited for this release because it brings something we've been working on for quite a while now, which is the Go supervisor. And just as a small introduction, the current node is not a single thing, but is made of several microservices interacting with each other and with external dependencies. So in practice, you need something like Kubernetes in production and Docker Compose during development to actually, see it running. And as we had teased last month, we've been working towards Monodo, a monolithic approach to the rollups node. And the Go supervisor is the first step in that direction. As the name implies, it was written in Golang, and it is a supervisor, a program that starts and monitors other programs. So in practical terms, what changed is that now instead of several Docker containers, one for each service, the node is now a single Go binary executing the raw services internally. So two nice things about it are that now it makes it easier for us to modify the services without breaking compatibility, and that now you can build and run the node natively on your machine with a few extra steps, may I add. Another big change is that the Rollups node now exposes a single entry point for its APIs. We have several of them, each with its own purpose, going to its own service. And that meant that the node had to expose several ports. The clients should be aware of those ports to communicate correctly. And now, to make everyone's life easier and reduce the attack surface, we have now a reverse proxy inside the node handling all the requests. So the APIs are the same, but they now share a single entry point, which is configurable via environment variables. And talking about environment variables, they have been consolidated in a single TOML file. We have set up automation to generate code and documentation from it. So this file is now the single source of truth for the node's configuration options. So you can check the docs or the config.toml file inside the repository if you want to check about the node's configuration. And another great feature of this 1.3 release is the support for the Sonodo validator node. So by default, the node requires an Ethereum account to make claims at the end of the app box. But for a node runner like Sonodo, it is more cost efficient to share such an account between several applications. So we've added a configuration option to disable claims in the node, so Sonodo can take advantage of that. We used to call this reader mode, but to avoid misunderstandings, we're not calling it that anymore. Just to make it clear, what it does is that it disables the claiming, the node claiming to the blockchain at the end of an epoch. Simple as that. And last but not least, there have been some quality of life upgrades to the documentation and tooling inside our repository. The main goal was to make it easier for people to onboard new people interested in participating in those development or simply wanting to tinker with it. So you guys can check it out on our Git repo. And that's basically all I have for you today. Thanks for your time, and questions and doubts can be asked here in the chat. You can also hit us on our Discord channel. And just to a reminder, there's already a release candidate available for version 1.3. Anderson just notified us that Apple Python is already using it, running on Sepolia testnet. So if you guys wanna play around with it, it's already available, and that's pretty much it. Thanks.
Oh, thank you, Davis. Also, nice news from the Node reference unit. Anything you want to add, Lineu, or we can move?
No, that's good. Thank you for the presentation.
Yeah, great job.
Thanks, everyone.
Great job. We already have some questions appearing in the message box, which is nice. So, guys, please don't feel shy. Put everything you want to know about what our units are presenting. Okay, let's move. So, Pedro, contract.
Yeah,
Welcome.
Danilo has the presentation, and today Guilherme, a member of the on-chain contracts team, going to do the presentation.
Hello, everyone. Welcome to another dApp recap. Happy birthday, Diego. Not gonna forget you. So let's go. Next slide, please, Danilo. So this graph shows the issues on GitHub on the month of January. As you can see, in the start of the month, we had a lot of issues opened, and by the end of the month, I think we only have one for the 2.0 milestone. So a lot of progress happened there. Next, please. So I'm going to list the main changes. First, we implemented the output unification part 1 front. Next, we also implemented the input simplification front. And more input metadata was added, taking advantage of the input simplification. So we've added the application address and the chain ID. This will help the dApp backend development, because application address will be available in every input as metadata and not as payload from the dApp address relay. And chain ID will also allow the dApp backend to be blockchain agnostic, so you can write your backend for Sepolia or for a mainnet. And so if you're listening to any specific contract whose address may change from the network, you can route that by the chain ID. We've also added value to vouchers, and what this enables is cheaper and simpler Ether withdrawals. So before, you'd have to call a function from the dApp contract called withdraw Ether. So with this new field, you can just have the destination be the recipient, and the value field has be the amount of weight to be passed via the message call, and the payload can be empty. Or if you're calling a contract and you're actually calling a payable function, then this can be the function call. We've also released a release candidate for the NPM package and Rust bindings, so it's available for testing by other teams. Some other changes are improvements on the documentation on local development. Local deployment. Thanks to the node for pointing this point of improvement. Next, we are also publishing Rust bindings for pre-releases. This might be useful for Dave, maybe for the node as well. So we've added a new GitHub workflow that does that automatically on every release and pre-release. We've also moved the custom errors to the interfaces. This should help developer experience, because if you're using any language bindings, for example, Ethers, RS, or VM, they should decode errors automatically if they're available on the interface API. And we've also removed the dApp address relay, because the dApp address will be available as metadata to all inputs. So there's that. Thank you.
Thank you, Gui. Danilo, who will be the next?
I think it's me.
Hello.
Yes, and happy birthday, Diego. So let's be talking about Dave. So we are reaching the end of our first larger milestone, which is having this like concrete, nice showcase of Dave for compute. And what we call compute, we just mean it's like the rollups, but without inputs, you know, it's just like this computation that runs from start to finish. So that's what we call compute. It's just you're proving a computation from start to end. And then if you add inputs to that, then it becomes rollups. So we kind of split the two tasks because it's easier this way. Yeah. So we're reaching this first milestone. So I guess those two first tasks are related to that. We need a way to there are configurations today, and then we need to know which values to set in this configuration, and it's very application dependent, and also it depends on the version of the emulator. The emulator is always improving, and when the performance increases, then we can change these constants, and it will improve the performance profile of so now we have this framework which estimates all of that, and we have a very nice computation that Carsten has provided us, which does some crazy the bootstrap stuff. It's kind of like installing a whole Debian distribution on a Cartesi machine, some crazy shit, and we've measured all the constants, so we use that computation as input for our framework. It spit out the values, and then we ran the whole day on that computation. So it's like this stress test, because it's like a long, heavy computation, you need to leave your machine on for a long time, and it worked. So we are really approaching this milestone of day for compute. We just have to figure out now what can be a nice, showcase application. We're thinking something like something silly, something fun, like Doom, or maybe, some video processing, adding sunglasses and some video somebody uploads, something like that. Yeah. So that's the first tasks that we are attacking, that's front, number one. And then there's the second one, which is the rollups, which we're doing in parallel. Like I said, we have compute, and now we have rollups. And we're advancing on that. There are a few features there that you can see. It doesn't really matter the details, just to say that we are advancing on them as we speak. And the milestone for that, the final one, we want to have a honeypot running on Dave. And yeah, that's all I have for you today. And nice background, Claudio.
Thanks, Coutinho. And I would like to invite the community to bring ideas for this showcase application for Dave. We have our Discord open for all community members to put ideas. I suggest the channel ideas and use case. So feel welcome to our Discord. Bring ideas, okay? Okay, Danilo, let's continue.
Oh, hi, can you hear me now?
Okay, yes.
Great. So I'll give the updates of the Explorer unit. Bruno is in a different time zone, so I'll give his updates. On the Cartesi scan application, they improved the display on smaller devices like mobile or iPad. The inputs table, and in general, all the tables that we use in the Cartesi scan are now more presentable. And they also fixed a few bugs. They fixed the false warning when adding a contract address when you're doing a ERC20 transfer using the Cartesi scan UI. And they also improved resilience of the input conversion and encoding. They are working on supporting NFT transfers. They are also working on executing vouchers using the website, using MetaMask, right? And they also working on searching for inputs. So on the Sonodo unit, I can give the updates. We released 0.10.4 during this month. As a feature, it only has like a listen port to the run command. So you can change the listen port in case the port we use it is busy. But we also fixed a few bugs. We fixed a file permission issue that's caused by, usually it's caused by the Docker daemon. But we changed a few things on how we use the Docker build, the Docker daemon during Sonodo build. And there was also a bug that we fixed related to JSON output of some commands. And I will do now a sneak peek of the Sonodo deploy feature. So Sonodo deploy is a major feature that we've been working for a couple of months or even a bit more. It's related to running applications on testnets or mainnet. In the first version, we will support, as the Cartesi framework supports, we'll support Ethereum, both mainnet and testnet. We'll support Arbitrum and Arbitrum on the testnet, and also Optimism and Optimism on testnet, right? So we already have some documentation available as a preview in the documentation website. So I will explain very briefly how the deploy works. So the deploy is, you do the deploy in two steps. One step, you have to publish the Cartesi machine that has your application to IPFS. IPFS is the chosen method that we are using as the de facto way of doing file sharing in a Web3 way, right? So you publish to IPFS, you can choose whatever IPFS method you want. You can run your own IPFS node, or you can use a third-party service provider like Pinata, which is a famous one. There's another one called NFT storage, which gives you free storage for IPFS. So, or you can run your own node as I'm running in my machine. You can run IPFS desktop or a command line node. It's pretty easy to run an IPFS node, right? So the first step, as I said, is publishing the Cartesi machine snapshot, as we call it, to IPFS. And the second step is to interact with a smart contract on the base layer you choose. There is a smart contract that is called validator node provider. If you want to be a provider, you can deploy your own contract, or you can use a contract that a provider gives you the address, right? So the Sonodo service will have his own contract, but you can create your own. Then during this interaction, you actually deploy the application, and also you fund the application somehow, right? You have to pay for the provider to run the node for you. This payment uses a ERC20 token. The option of which token is used is made by the provider itself. It can define whatever token he wants. It can be like USDC or whatever token he wants, right? So these are the two basic steps. I can give a quick demo. So I have here a Sonodo application on my local machine. I can run Sonodo build, as those who already used Sonodo before is already familiar with. It's building the application, running the Cartesi machine, and putting the machine in a state to accept inputs
Danilo,
from the base layer. Yeah.
Sorry.
Oh, you can see my screen, right?
Yeah.
Yeah. Sorry. let me share the full screen. Can you see now?
Yes.
Yeah. So I ran Sonodo build, which builds the application using Docker and then runs the Cartesi machine, puts the machine in a state to receive inputs from the base layer. This machine it's like the Genesis machine of the dApp chain that you will launch. Under the hood, what this actually does, it creates the Cartesi machine snapshot, which is represented by this file that is at .sonodo/image, right? So when you run deploy, the deploy command, this is the hash of the machine, which is like the Genesis hash of the dApp chain. This is the IPFS node that I'm already running locally, right? So it will publish the machine to that address. So let me skip this step. So as an option, if you, instead of running a local IPFS node, if you want to use a service, for example, like an FT storage, that has like a UI that you can upload files, for example, you could instead run Sonodo package. Sonodo package will create this file, and you can just go to the website and upload this file to the service, right? So after the machine gets uploaded to IPFS, this is the address of the machine on the IPFS network, right? This is the CID, as we say. Then the next step is to, as I showed in the diagram here, the next step is to interact with this smart contract, right? So I'm running locally UI that interact with this smart contract. So this is the deployment UI, right? So here you can put in the CID of the machine. So it already fetches the machine from a PFS, gets the hash. So what is the size of the machine? You can see the details of the machine, all those files that I just showed. The next step, you choose the base layer. As I'm running locally in a development environment, I have a local Foundry network running, but in production, you would select one of these supported networks, right? But as I'm testing, I'm running locally. So this is the address of the provider, right? So what is the address of this contract here? So I already have a contract deployed on my local network. So if I put the provider here, you can see details of the provider. You can see what is the authority that is validating your application, what is the price. In this case, it's just a test token that I created locally. As I said, it could be any token, any ERC20. So this is the price for the amount of days you want the provider to run the node for you, right? So if I want to pay for 1 day, this is the cost. If I change the amount of days, you can see the price changing here. So, and these are the two interactions that have to do with the smart contract. The first one is to approve the spending. This is very common when you are dealing with ERC20 tokens. You have to approve the spending first. That will pop up MetaMask, approve the spending, and after the spending is approved, you can actually deploy. So what happens in the deploy is that the transfer of this amount of tokens will be made to the provider, and the smart contract of the application will be deployed on the base layer. So this is the address of the application that was deployed, and now what is missing here is that the provider will watch the blockchain, see that you want them to run a node, and they will run a node, and you see here the address of of the node of the application that you're deploying, right? So this is not 100% ready yet, but this is just a sneak peek of how the deploy will work in general, right?
That's it, Danilo.
That's it. That's the update for Sonodo.
Wow, incredible. This dev recap is really incredible. Uh, so I think some of the community needs some time to take a breath. Just before we start, we already have we still have some units to present some results. So until now, we have the machine emulator unit, the contracts, and the node units. The units responsible for the core of the Rollups SDK. They presented their achievements in the last weeks. So then we have Dave with Coutinho, which is the work front on decentralization. Dave is our fraud-proof system that we are developing. And then we started to have some clients of our rollup ecosystem. We started with the Explorer, and then Sunod, which is this infrastructure that will allow us also to have a better development experience, but also to deploy our dApp on testnet, on mainnet. Okay, so this is some enclosed context of what we had until now, and then we have other clients to of roll up and the experimentation work front. So I will call Fabio Ciro, which is the leader of our convenience and tooling unit, to present. They are onboarding because we are really interested in improving our developer experience. And so having these units taking this responsibility to bring a better experience for the developers with tooling and convenience is very important for us. So Fabio, please welcome to stage and just present yourself and the unit, please.
Hello, everyone.
Hello.
Hello, everyone. Are you listening? Hello. Well.
Yes, I listen well and clear, Fabio.
Okay. Nice. I'm here from Calindra. I'm really happy to be here with you guys. And let's share with you what we are doing right now, this first month that we joined this incredible team. Let me share screen. Oh, I need to do some kind of. Yeah, I need some permissions here. Sorry. Because I'm running on Mac.
Nilo, can you help with that?
No, I'm set up in here. Just because this is the first way that I need to reopen the Discord. I will be back.
Okay, no problem. We can switch and then start. Yes, let's start with Carl with the app implementation unit. Yeah, and then you come back. Okay.
Okay.
Okay. So Carlo, please welcome the application experiment unit.
Hey guys, can everyone hear me?
Yes, a little bit low, but we can hear.
Okay. So let's go for a monthly dev recap. So first news is no longer prototyping support. Now we're called App Experimentation Unit, as Claudia said. So what have we been doing this past month? So this new unit scope, it's much more focused than before. So now we focus on app experimentation mostly. It can either be new stuff or it can be expanding something that was cool and promising that was done before. And another change that happened is that now we have one of the best people here in Cartesi. I love him a lot, which is Max, which is our BD genius, and he's on board on our team. And he's taking our strategy and all this crazy stuff in which he's great at. The first project we're running, as we gave a glimpse on the last one, is expanding Word Arcade. So on this past month, we've been doing the rewrite in Python. This high-level framework opinionated that Linus is building called Cartesi app is also evolving along with it. Every time we have a new feature, something new that we want, Cartesi app gains a couple of new tricks. There's this new UI that Arthur has been developing mainly, and we have some new DevOps tooling that we have. So for instance, our front end now is fully automated. It's just a matter of pushing to the main branch, and we have Kubernetes and a lot of stuff that just automatically deploys it. So time for a demo. So news, Word Arcade no more. Word Arcade is dead. Long live Rives. So Rives is a RISC-V verifiable entertainment system. So it's this virtual console, which is RISC-V based and is deterministic and verifiable.
Hey, welcome to Rives, the RISC-V verifiable entertainment system. Rives is a fully on-chain fantasy console, which allows you to prove your game scores in a decentralized way. So how does it work? After selecting a game, you play it in a reproducible RISC-V virtual machine directly in your browser, which then generates a log file with your moves. To join the leaderboard, your log file is submitted and replayed in the Cartesi VM for verification. So let's try it out. So from the landing page, click on Cartridges to get started. From here, you can select a game on the left-hand side. As you can see, Snake is pre-selected here. Now there are different tabs available, such as tournaments and leaderboards, but let's get playing. So to get started, click on the power button here, and that will load up the cartridge. And in order to get started, let's click on the play button, the top left. As you can see, I'm playing Snake at the moment, and my score is going up as I'm eating these little red dots. And I died. Yep, so I just died. And at this point, what I will do is essentially connect my MetaMask wallet. And as it's connected now, I can just go ahead and submit my log file by clicking on this button and clicking on confirm. And my transaction is confirmed. And at this stage, I should appear on the leaderboard in a second. And here's my score. So essentially my moves were rerun on Cartesi machines, which essentially allows me to prove and verify that the score is accurate. There you go. That's on-chain Snake using Rives. Stay tuned for more.
So yeah, we have it deployed at Rives.io. So you can check it yourself if you want, give it a little push. It's under heavy development, so do expect things to break and to change a lot frequently. But yeah, that's the overall of what we've been doing. And if you got any questions, suggestions, feedback, we're all here. Okay?
Great, Carlo. Arthur just wrote on the chat that it's available on Sepolia. And nice, let's put some questions. Take this time to have the questions on the chat, okay? Fabio, are you ready now?
Yeah, I believe so. I will try to share my screen. Oh man,
Okay.
the button is not working. So, but okay, it's our first time here, and I will do my setup better next time because okay, now the share button appeared. So, I'm sharing my screen right now. Thank you,
Yeah,
Discord.
I can see it.
And okay, let's go. We are responsible for the high-level framework. We are onboarding all developers. That's our mission in an easy way. And so this month, we take a look at the role. we did our first PR approved by Danilo Tuller with the Quick Start Guide. We're planning to support all the NFT standards like multi-token and so on. And we do some conversion of the rock, paper, scissors to use the high-level framework written by Lino and Carlo. And we tried no node, and it's really fast. It's really smooth. We run it with the rock, paper, scissors, and man, it's fast as a hell, man. It's really nice. And we deployed the rollup contract just to see how it works. We deployed it on Syscoin Rollups because before we are trying to explore the DA, data availability. And also we are exploring the Rollups node, all the code written in Rust, and Sunodo also. We are changing, compiling the code, a lot of code, man. Just take a while to compile all those codes. And we wrote a first draft saying the command like fetch it from NDA and a hash. And of course, the silly draft, we just put this tuple on the input box. And in the advanced node, advanced runner, in the rollups node, we just hit the CDN from Syscoin and fetch the file and put it on the input box. That's it. I don't know if someone asked something. Rollups node and Syscoin. We made some modification on advanced runner to receive a specific input and get this blob from Syscoin. But again, it's just a draft. And we are planning to do an evolution from the REST. Like if you use any framework in the backend, like Express, Nest.js, Flask, Django, you could, in the future, do the same HTTP request for your dApp inside the Cartesi machine. We wrote our first technical proposal, things like that. And in the future, we will bring more details about it. Okay?
Thank you.
I think that's it.
Thank you, Fabio. Please share the link for your proposal on the governance forum on the chat so people can click. Okay?
Okay. Thank you.
Thank you very much. Karsten, let's bring those breaking news and all beautiful experimentations and explorations that you do.
Can everybody hear me just fine?
I'm hearing you and I can see your screen.
Good. So, I can't present anything more impressive than what Eduardo did today, so you'll have to deal with what I have to present. So, a couple of updates on Lambada. One of the things we did was kind of like making a session where we did a complete code walkthrough to help people understand what Lambada is and how it works in terms of like the modular ecosystem and so on. And we also did a second session together with the dApp team where we kind of like went through all the stuff about sequences and bridging and those kind of things. So if you ever want to understand how this looks like from point of view of the modular world, this is a video you can watch. Kind of like our main plans at the moment is to spread our knowledge as much as we can to allow the organization to transition more into the modular world, having devs and developer advocates built with Lambada and build itself. But kind of like more technical news, we have also been doing something like what Danilo was doing with having hosted base machines where we're optimizing with having sparse images, which means they take up less space on disk, for example. Allowing the guests, as in the applications, to have access to more metadata, like, for example, what's the current layer 1 block. We also added support for the newest Express Sushi Portal testnet, where they also in the documentation referred to Lambada in the documentation as a way to adapt Expresso together with the Cartesi stack. We've also been playing around with kind of like having more attestation of computation, which can be useful to kind of get a very, let's say, higher confidence in the state of a chain, and working on kind of separating chain information out from an app to kind of benefit from having kind of like many of the same kind of like chains. On the Cartesian and co-processor side, one of the things that Eigenlayer is doing is that they are pushing kind of like a long road for what's called AVSs in the system, where basically it's more like whitelisting system. You need to do security audits. And the effect we see is that kind of like there will be more general purpose systems that are going to be deployed initially. It's not going to kind of like be experiments, because they will have a much tougher road when it comes to kind of security and, let's say, getting people convinced to run their nodes. So our approach is kind of like to make a very solid co-processor service that scales on a first deploy, because there's a very long way to and delays in upgrading and kind of delivering new functionality, as in you can't do it in a very agile way. So one of the things we're doing at the moment is doing kind of like more off-chain batching of kind of like the tasks for the co-processors, and kind of like other functionalities that make sense to bundle together with the deployment. Philippe has graciously volunteered to be a technical liaison because of time zones of the Eigenlayer team and us. And yeah, that's pretty much it for the co-processor side. And on Cartesi and Bitcoin, the BitVM guys, because they're doing kind of like, let's say, the Bitcoin script side of things, have built all the instruction set with the kind of like the challenge games to kind of support the transpiler we've been doing, and successfully tested the RISC-V test cases on it. You can see it on this link here. And we've also been working together with Chainway, because they are bringing general purpose ZKP verify on top of this transpiler, which is very, very useful for us to confirm we'll bring in Cartesi virtual machine-based chains in a validated manner. Some of you might know about kind of like verification games and so on, and know that, let's say, from the moment that a challenge starts in a Cartesi verification game, it kind of starts from 7 days, and with every move, you kind of like, let's say, you kind of like, you have to do all the moves within 7 days. But it's impossible to kind of like make this kind of like chess clock in Bitcoin. So every single time that you do a bisection response is 1 week. So at a ballpark for, let's say, doing a ZK verification, it would take like 35 weeks to do a bisection. So whatever you have in there better be worth it. So that's something that kind of like also blocking something in this regard. But the BitVM community is very strongly pushing this direction. And of course, Cartesi, as we are awesome, we are taking part in that discussion. We've also done a bit of outreach. The Avail network whiteboard session finally came out. And also we are participating in the Rollup podcast presentation. I'll throw the links into the chat afterwards. And yeah, that's pretty much the update from the compute team side.
Okay, Karsten, thank you. I would like to invite everyone to watch the Lambada 10,000 feet presentation that Karsten mentioned. It was really nice and a nice way to understand better the idea of Lambada and its possibility. Okay, so that's it, guys. I think our units presented their work, a lot of awesome things. And now I will invite Milton to open the question and answer session of our call. Please come stage, Milton. Hello, hello.
Can you hear me?
Yeah. Yes, very clear.
Hello, everybody. So, Claudio, are you staying around? No, he's not. Okay, guys. Nice to see you. This was a very, very interesting session. I think everybody agrees on it. I have, as always, a couple of questions of my own, but we have some questions that were placed in the chat and that maybe we could explore a bit. So one of them was about asking the node team about minimum requirements. I think Linneo did answer a bit in the chat, but I was a bit confused by the question and the answer, because if you want to go on stage, Yves or Linneo, I think it's you can't really have minimum requirements for a node, for an app chain, because it depends a bit on which computation you will run, right? What the application is doing, right? So differently from normal nodes, that's you can have, I mean, you can have a minimum requirement for just running the bare thing itself, right? But not for each application, may be more demanding, right, on resources. How do you see it?
Yeah, that's true. I thought the question was about the requirements as the steps to run the node without Docker, something like that. In that case, it will be documented, but in terms of computational requirements, it's up to the application itself. It depends on the application running and the requirements of the application, the amount of memory and the amount of processing power.
Yeah, but the node itself will not demand much, right?
Yeah, the node itself doesn't demand much. Most of the processing is done by the Cartesi machine, and the rest of the node is very lightweight.
Cool. Okay. Then other question that I have here is about use case ideas. I think it was in the context of experimenting with Dave. So someone was suggesting tokenization of real world assets. I'm not sure if Karsten wants to talk about that one, or even Coutinho, if that's something that you see as possible in terms of playing around with Dave to actually validate. There are some applications that are handling those kinds of things, right, Carsten? That you were. Not sure if Carsten is able to come on board, or you're talking about some other things. Okay.
Yeah, I was just saying that I'm happy to kind of discuss this in parallel with Michael, also talking about experiments we're doing with sequencers and real-world assets, registries, and so on.
Great, but do you see is that something that's with the current state of Dave is something that we could already experiment with, or we need it to?
I think we probably need Cartesi Rollups in one way or the other.
Yeah. Okay. Okay. So in the Dave arena, I did have one question for Coutinho, which is, you said you were stress testing it, and I was curious to know if you already explored adversarial scenarios, where, for instance, you can have like out of 5 participants, you have like 3 or 4 are trying to cheat, and the verification game of Dave like catches him.
Yes, we have tested with like adversarial conditions, but like on our local machines, you know, so it is like still a manufacturer test. It isn't like something we put like on chain and then it survived like random people attacking it. But what we have is we have this Rust node, which is the one that we're going to use in production. And we have the Lua node, which is the one that we use like for testing and prototyping, you know. And on the Lua node, we've actually implemented multiple strategies, you know. So we have like the honest strategy, which is, if you're running the honest strategy using the correct machine, you know, you will always win. But you could use the honest machine. Well, sorry, you could use the honest strategy, but then you load a wrong machine. So we've tested with that. But we can also change the strategy to be something like don't answer the questions, you know, just put a claim and disappear, you know. So we have tested with multiple players joining in the game, and the players running different machines and running different strategies. And even the Rust node and the Lua node, both honest, you know, and they always win. So yeah, so the honest thing will always prevail. That's what we're getting, and it doesn't matter if it is the Rust implementation or the Lua implementation. It only matters that you're using the right machine with the right strategy.
That's really cool. So we can say that we are pretty confident that the algorithm works, and implementation of the algorithm works, right? We're just not stress testing Sybil attacks, I guess, something like that, right? Things.
Yeah. And like we're only testing like scenarios that we can foresee, you know. But yeah, it's still on a single laptop, you know. I don't know if you manage to add like 1,000 Sybils. Probably you need more compute power to verify that scenario. But yeah. That is the role of the Lua node that we have, you know. Like we first started it as a quick way to get something done. But it has now this special place, which is we can use it to really like bash Dave with different like modules, you know, like different strategies, and see if they survive. And it just survives, you know. The thing is nice. I'm proud of it.
Great. Thanks a lot.
Thank you.
I have another question for Eduardo Bartel. When you showed, actually, you're already talking about that. Carlos already talked about that. When you showed the remote debugging possibilities, I was curious to know if you or somebody was already envisioning coding in VS Code and debugging stuff that's running inside a Cartesian machine and things like that.
I think it's possible. I'm not a user of VS Code myself, so I don't know if VS Code has a plugin for remote debugging. Probably it has, but yeah, I think you could use VS Code also, and other programming languages that has remote debugging support.
Yeah, because you can do, you showed both things, or you could edit the files in the host and have the Cartesian machine executed, and then you could debug it from the host as well, right? You can do everything from the host.
Yeah,
Anderson is pasting some documentation there. Not sure if he's familiar. So Anderson, you're the guy who will do it. Thank you, man. Sorry, Anderson, you were saying, Eduardo, you were saying something else.
Yes, you can also run SSH inside the Cartesian machine and connect to it, like Anderson is suggesting. I have tried this should work fine. So if your remote debugger uses this, you can use this, yes.
Yeah, so Anderson is asking if you can connect to the Cartesian machine from the host. I guess you can, right? You can run a web server.
Yes, the demo I showed is doing that. It's running a server inside of the Cartesian machine, and then the host connects to it to debug the application.
Great. So this is fantastic, really fantastic. Thank you.
Yeah.
All right. Don't know if anybody else has any question. Please put it in the chat. If you're still around, Carsten, I would like to ask you a bit about the Bitcoin VM that I was curious about. Those long, the absence of clocks and long times. So, in your opinion, the path to get some like settlement on Bitcoin of some crazy Cartesi Rollups thing or computation would be via ZK and not a verification game, because a verification game would take years to end. Is that it?
Yeah, so that's kind of like how it looks at the moment. The thing is that a Bitcoin script does not have direct access to, for example, the block number, right? So we can't use the usual tricks and say that kind of like just count down from this block number. The fact that it is settled through a ZK proof is not a bad thing, just for good measure. It just basically means that there's a step between the Bitcoin script virtual machine and, for example, something like our own challenge response schemes, for example. So it might be that there's some kind of like subchain that deals with actually, let's say, having full-blown RISC-V games on top, for example. Which is also, for example, therefore we can settle into Ethereum with in the future as well. That it might be that we are settling the result of a game that happened in, for example, a sequencer. But indeed, it is like crazy that it takes so many weeks. But I think that people are looking into, can they somehow go ahead and improve that timing somehow, like for example by doing, let's say, 10 array searches, for example, etc., etc. But I think that there's a lot of, let's say, innovation and interest going into it. But at the end of the day, who wouldn't want to make the Bitcoin rollups applications for the Cartesi machine, because it's just so much easier, isn't it?
It's easier to do what?
To do applications for Cartesi machine.
Oh, right. Yeah. If we can settle those on Bitcoin, yeah. But it's being the Cartesi machine, we can have all the things that you can do on Linux and it's there. All right, thank you. There are a couple of other questions here. Thank you, Carsten. So I think Eduardo was just asking if there was any difference in performance between Lua and Rust for the Dave node. And what are the difference advantages of using Rust versus Lua? I think Rust will be maybe the production run, and Lua is more for experimentation. Is that it?
Yeah, that's exactly it. So in Rust, we're gonna add like a lot of features that you really don't need in this prototype node. So we're gonna add like some sort of persistency on Rust. For rollups, we're gonna like save all the inputs on some database. We also need to store persistency the commitments. Then we wanna take like snapshots of the machine, like save the whole machine to disk like every 10 minutes or something like this. And all of this is the kind of work that you don't need on a prototype node, but you need on the production one. So we have these different necessities between a production node and a prototype node. And we just feel that Rust is a better language to implement all of that. And then we're going to keep Lua as this like prototype stuff.
Okay, thanks a lot. So I think this is it. Anybody else? So there was a question here about testing the Rust node against the Lua node. I think that was already answered, that they worked one against the other. So guys, I think this is it, unless somebody has a last minute question. And this was a really impressive call. Thank you for everybody who presented. The presentations were awesome. Virtual.io and the new node with a single binary, the new contracts, Dave, Explorer, Cartesi scan, sneak peek into Snowdo deploy, the new rewrite of World Arcade into Rives. Rives or Reeves? I think it's Rives, right? The great start of the convenience and tooling unit, updates on Lambada, the coprocessor, Cartesi on Bitcoin, so much stuff going on. Thank you, everybody. Okay, and that's it, guys. Thanks a lot for everybody, and see you next time. Thank you.